Hello. In this video, we're going to be building on some previous work where we created a local Docker deployment. And to do that, we're going to take advantage of Git branching to create essentially an alternate reality of the code for that GitHub repository where we can run experiments and manage our files without having to worry about keeping copies of things that we don't want to lose because they'll be saved in a branch in Git. So the goal here is going to be to take this deployment repository, which if you're not familiar with, there's a previous video where I create this repository essentially just to use Docker Compose to create a local deployment of a static web service that has a couple of different containers running at the same time. So you can go and check out that video if you haven't seen it, but what we're going to be doing is creating an alternate reality or another branch in which we follow the same basic patterns that we used for this one, except we're going to be doing a different goal. So the goal for this one was to serve a GitHub Pages app of this particular GitHub Pages site, and the new goal is going to be to serve an NGINX container with PHP, showing how PHP server-side code can run and behave together with NGINX. So it's a pretty simple task, but we're going to be building on what we already have here. So I'll get started just by explaining a little bit visually about how Git and Git branches work. So the first important thing to understand is that Git repositories typically track remote repositories. So remote means they're off somewhere else on the internet. They're on some other computer somewhere. And remote are typically, you can have multiple remote locations where you're pushing code to, but generally you just have one, and it might be somewhere like GitHub. And the typical name for this is origin. Now you can have a name whatever you like, but origin is the typical name that's used. So when you say you're pushing to origin main, that is the main branch within the remote location called origin, which might be a GitHub repository or a Bitbucket repository or a GitLab repository or some other Git location on some server somewhere. And so what you do when you clone a repository is you make a local copy of the repository that is on that server. So you can clone that on your computer, your PC, or whatever computer, and you can put that in a folder, and that folder will typically have the same name as the repository, but you can actually name that folder whatever you like. So on that folder, in that folder, you're going to be able to track the branches that are in the remote origin. So you can track the main branch, and the way to do that is you just clone the repository, and if it has a main branch, you're automatically going to be pulling down changes from the origin main, and you're going to be pushing up changes to the origin main. Now where we get into branching is that you can take branches that have their own commit history. So if you think about the basic main timeline, you have main, and you might have a commit hash or commit number of 1, and then as you move through the timeline you go to number 2 and number 3, and it's all the same main branch along the way. So what branching allows you to do is say, I want to take something at a particular commit hash, a particular point in time for this branch, say it's the main branch, and I want to create a branch called, say, branch number 1, B1. And then this can have its own commit history where it can have its own future commits. So say 3B1 and 3M. So they can both have, they wouldn't probably have the same commit hash, but they can have the same, they can be the same commit after this point in time where you branched, and they can actually have different code here. So the code here can look like one thing, and the code here can look like something different, and they're not going to interfere with each other. And now you can always, in the future, choose to come back and merge these back together. So these might undergo many changes, and then at some point you choose that you want to take the this branch and merge it back into main. So that's beyond the scope of today's video. but that is an advantage to branches, is that you can run experiments in your branches that don't affect your main branch or whatever branch you start from, and then you can merge them back in at a later point. And I should also point out that you can branch a branch as well. So you could create a branch off of this, you could make a branch off of this, and all of these would be separate. So this is one thing, this is another thing, this one is another thing, and then this one is another thing. So all of those are separate branches. Now, when you have this relationship between the remote origin and your local repository, you can have different things on the two. So you could have, locally, you could have a main branch, and then you could delete your main branch in theory on your local. That doesn't mean you're deleting the origin main branch. And you could also just as easily create a branch locally called, exp for experiment, and you could run that experiment, and you don't necessarily have to push that up to origin main. But it is possible, if you want to push up to origin main, once you've created that branch locally, you can make your changes, and then you could decide that you want that to be tracked up in the cloud. And so the cloud, you can create using GitHub. You could create branches in the GitHub website. For example, you could create B1 up here. If you cloned when B1 was created, you would automatically get a B1 locally that you could use. But you could also take a local branch and create a branch in the cloud by pushing it up to origin/exp, for example. You would typically choose the same name. And that way you can have push and pull back and forth between your local exp and the origin exp, and also between your local main and the origin main, and not get those wires crossed. You can keep the pipeline keep things isolated so that you have two separate realities in which you can manage code. You imagine how annoying it would be if the only way to save some code, if you want to try out an experiment, was to create like a folder of experiments and put all your code in an experiments folder, and then pull it back out if you need it in the future. It's much easier if you can switch to a branch and you can delete things and reorder things and rename things, and then just bring back in changes from another branch later if you want to. So that pretty much covers how branches work. Last thing I want to point out is that you can have multiple folders on your computer that actually track the same remote origin. So this cloud here is the remote origin, and you could have a separate folder that has the same branch names, and it has the same repository information for that remote. It's just in two separate folders on your computer, and those folders can have different names. This one can be A, this one can be B. It might be the name of your repository when you cloned it by default, or you could change it to something else like A or B or anything you like. Now, someone on another computer can also clone your repository, and they could have that in one folder or two folders or three folders. The important point is that there can be many local repositories, not necessarily multiple remote repositories. So you are often only going to have one actual ground truth up in the remote origin, but then you will have multiple local repositories that are pushing and pulling to and from the remote. So let's start to look at some of these things a little bit more practically. So if you clone your repository, I'm just going to make a fresh clone, or you can go to an existing local instance of this repository if you have one of your own. So we'll just do cd into my code folder and git clone this, and this will give it the name Docker static app deployment by default because that's the name of the repo, but I can also put it in its own folder of my choosing, the name of my choosing. So I can say Docker DPL for deployment, and I could add a number to it. Maybe I have multiple versions of this, so I have 1 and 2 and 3 because I've cloned it multiple times, trying to test different things. So I'll just call it DPL1, and then we can code Docker DPL1. So you sort of have to understand a little bit about the difference between adding and committing and pushing for branches to really make sense. So let's say we have a README file and we just want to make a little mark to indicate what branch we're on so it's clear when we switch between them. So right now I will do a git branch -- list to just show what branches are available, and it's just the main branch, and the star indicates that we're on that. So if we did a git branch PHP, because that's the experiment we're going to be running, then we would create that branch, but you'll see I'm actually still on the main branch. I've created the PHP branch, but I haven't checked it out. So to do that, I have to actually git checkout PHP, and then I'm going to be on that PHP branch. So I can git checkout main again, and I can delete that branch with a git branch -d for delete local, and I can delete PHP branch, and you'll see that that's been deleted when I list. So if I want to do that, those two steps of git branch and git checkout in the same step, I can simply do a git branch git checkout -b for branch, and then name it PHP. So it's going to switch to a new branch which it calls PHP in one step, and then we can see we're on the PHP branch. So what happens if we make a change? Like we say, okay, we have these alternate realities, so I want to say, haha, this is from PHP branch. So that's a change, and if we do a git status, that will be registered because this is a tracked file. Now you'll notice there's some git ignoring here, some very strict git ignore policies in this repo, but the README is not excluded. So the README is being tracked already, and so you could see git branch. I'm on the PHP branch, and I have made some unstaged changes. So I haven't added them, I haven't committed them, and I absolutely have not pushed them. So what happens when we git checkout main again? And you can switch between these all day long, but what happens is your branch is up to date with origin main, and we switch to main. So this is a deceitful message if you don't know a lot about Git, because the commit history is up to date with origin main, but if we do a git status, you'll see that there are actually uncommitted changes. And so branches only can manage changes which are committed, not changes which are unstaged. So when you make local changes, those are unstaged changes, and that's why we have to do a git add and then a git commit in order to commit those to our local repository prior to pushing to our remote. We have to actually stage those so that we can select the files we want to be included, because we may change lots of local things and not necessarily want to drag that around to different branches. And so only those committed changes are going to be saved. So to illustrate that, we can go back to we can git checkout PHP again, which was the place we would logically want to commit this change, and we could git add readme, and we could git commit -m, making a mark from PHP branch, and then git status. You can see that the changes are committed, and there are no unstaged changes. So what happens now when we git checkout main is that we lose those changes in visibility because we've switched to the main branch, but we haven't actually lost those changes for good because they are on our other branch. That was the whole point of the branching. So we can git checkout PHP, and there come back our changes. So what happens if you had some pending changes? This often happens where you'll have some pending changes, more from PHP, and then you want to come back over here. You have pending changes, git status, and you want to come back over to the main branch just to do something on the main branch. Your local changes to the following files would be overwritten by checkout. Please commit your changes or stash them before you switch branches. So it's telling us we should probably commit or stash. So commit you saw, but what does stash mean? Stash essentially says, let me deal with these local commits. I just want to put them to the side for a second. I don't want to get rid of them forever. I want a little copy of them kind of cached locally in case I want to grab them back. But right now I just need to get these local changes out of my head. I need them out of my repo so I can commit specific things. And so the way that you would do that is it will be scary because it will make your changes go away, but it will put them inside of your git stash stack. So if we do a git stash, that will stash all our local changes, and you'll see our change disappeared. So where did it go? Git log, our commit history does not show any commit for that because we didn't commit the code. So it seems it's disappeared, but if we do a git stash list, we'll see that there is a we have this stash that was based on the making a mark from PHP branch commit, but it actually has some work in progress, WIP changes. And so then we can easily git checkout main, and we have no issues going back to this old version of the README, and we can come back over and git checkout PHP once we're done doing whatever we needed on main, and we can unstash our changes so that we can use them. So git stash is like a stack. So if we made more changes, we would have git status, we would have some changes, and if we git stash pop, it would pop just means take the top thing off the stack. So if we git stash list, you'll see there's we need to git stash those changes, and then you see git stash list, we have the previous changes and then these changes. So if we git stash pop, that'll pop our first changes, and if we git stash pop again, you can see commit your changes or stash them before you merge. So it knows that it's going to disrupt things if we do this. So in this case, what I want to do is restore, meaning I want to undo these pending changes that I brought back from the stash. So I'll do a git restore readme, and this is going to take it back to wherever we were, where the last commit is. So the last commit would be when we just had this part here. So now that stashed change that we brought back, now that is gone forever, and we can do a git stash pop again to pull back the change from before, and then we could git add dot and git commit dash m more on PHP branch. And so now it's easy also to git checkout main and then go back, git checkout PHP, and those changes are going to be there because we committed them. So that's why it's important to make these granular commits where you can easily track that history using commits, because stashes are more of a kind of like, just let me get this out of my head for a second and I'll bring it back in a second. But they're not really a place to store many changes or commits over time. You would want to use commits for that. So now that we have these, you can clearly see these are two different realities. Let's see what happens if we try to git push. Well, it's going to say the current branch has no upstream branch. So it's catching us from making the mistake of overwriting our main branch in GitHub with this local branch. And you can see in here we have a main branch, but we don't have any other remote branches despite having these when we do a git branch list somewhere in my history here. We have this PHP locally and we're on it, but we don't have that in the remote. So for the first time we do a push here, we have to do git push set upstream origin, or git push -u for upstream of origin, the name of the remote, and then space, and then the name of the branch we want to call this in GitHub. So we want to call this PHP in GitHub as well, and that will allow us to create a new branch in GitHub through the push. And you'll see that here PHP had recent pushes, and we can switch to the PHP branch in our code viewer and see the README has those changes more from PHP, whereas our main branch is completely safe from those changes because we pushed to the PHP branch. So now you can be 100% sure that these are alternate realities. And the nice thing is that we can, when we do a good push again, we don't have to say that upstream origin. It already knows, since last time we had set that up to track origin PHP. We're going to automatically have this PHP locally to remote relationship, and then when we check back out, get checkout main, and we get push, that is going to push to the main branch and not to the PHP branch, which is what we would want. So that keeps everything kind of aligned. Now let's actually get to making some changes on our branch, which is now set up locally and it's set up in GitHub. Let's get into the core of those changes. And remember, now that we're on this branch, let's double check that. Always want to be confident you know what branch you're on currently. So git branch, git checkout PHP. So now we know we're on the branch we can essentially destroy as much as we like. And I'm just going to start making actual changes now relevant to the task at hand. So the new task is not going to be to create a local deployment to serve this. This is a local deployment to run server-side PHP scripts integrated with an NGINX web server. And we're going to use a lot of the same strategies here, but this architecture is TBD, I guess, because we're changing the architecture. The prerequisites are the same. The testing notes are going to be pretty similar. Maybe we might not need Perl. And the usage is going to be very similar, except we don't need all these instructions probably in the middle about these different things, but mostly it's going to be similar. We can change the, like I said, change the number there for us. That's nice. But we're going to have to make some more changes to this as we develop it. We'll have to document it, but you see a lot of this, since it's based on what we already had, we get to save a lot of work by copying over, and that was the advantage of using the branch as opposed to a completely new repository where we have to copy in every single file individually to get started. I know for a fact I'm not going to need a custom Docker image to be built, so I'm going to delete the Docker file. I also probably would not need that in to be unignored in the gitignore. And now I can work on my Docker Compose services. So I have pretty much the same basic idea of like using volumes with NGINX, because I'm going to be building off of NGINX. But I want this to probably look most similar to this HP service, because I just want to use an NGINX image from Docker Hub and then use some volumes. So I'll just delete these other services here, and then I'll rename this service to the, call it the HTTP service, since it's going to be a web server. And I don't really want the watchdog service anymore, so I'll delete that one. Now in my setup scripts, things are probably going to be a little bit different. So here, creating a final project and a home page volume, doing a bunch of replacements. So a lot of this is probably going to go. Now I just want to easily exit this script, so I'm going to do exit 0, which just says leave this script with the exit code of 0. So if you can see, like echo reached 1, and then echo reached 2, you'll see that exit 0 is just going to leave the script early. So I'll do /scripts /init.sh. We get to reached 1 but not reached 2 because it's below the exit. So if I put that above, you'll see both get reached. So everything above here is going to be what gets executed, but I can copy things from down below since we're building off of a prior work. Now I am going to want to create a volume. The basic architecture here is I'm going to use NGINX to run a web server, and then I'm going to have to find some way to run PHP code, because by default the NGINX server is just serving HTML. It's serving static files. It's not really set up to do PHP, but it can be easily configured to work with a PHP interpreter. So this init script is going to have to do the same basic things with config and the HTML folder, very similar to the home page one. So I'm going to copy over the home page one, except in this case I'm not going to have multiple separate folders in volumes. I'm just going to put them right in the volumes folder because we're not going to have multiple volumes. We're just going to have one. So that may create a problem when we go to merge this with the main branch later on, but right now we don't care because we're in a completely separate reality where we can do whatever we want. So we will create the config and the HTML folders and then we'll clear them out. So let's just check that and make sure it works. And we got a volumes folder. We can create a new file and then it should get deleted when we run it again. Yep, same as it worked before. Now we're going to pull an Alpine container, or just simply run that and it'll pull itself. Pull that Alpine container and run it, and then copy some stuff and then stop the container. So I'll copy that code, and a lot of this stuff is just super easy because I've done it all before. So the only thing is I have to make sure everything is correct here. We don't have this final project part of that path anymore. And I don't have a separate one for homepage and final project. There's just going to be one. And same thing here. I don't really need this file name here because it's just going to be copied into that folder. This is going to be copied into that folder. The HTML folder is going to be copied straight into volumes. And let's see if that works. So now we get some boilerplate stuff here, all the normal stuff. And now what was done in this previous approach was some kind of advanced Perl scripting to do find and replace in these files. But you know, another way we could do this, which would be easier potentially, would just be to edit the files manually and save a copy of them, and then copy in our copy at a later time. So for anyone who was confused in the last video of doing all this advanced scripting that wasn't necessarily required, this was just one way to do it. Another way could be potentially much logically more easy for a beginner to get a hold of, so we can try that this time. So we'll just make some changes here and then make sure we mentally keep note of what things have been changed, or we could put it in the README and then we come back and make sure we get all of those changes later. So let's just see if we can use our basic setup, and without continuing with the PHP, let's just make sure we can get this thing up and running as sort of expected. So we'll get rid of these home page pieces here, just go straight to config and HTML, and everything else should be the same. Now because it's an NGINX, it's going to have to be, we should name this container HTTPC, and then the ports are going to have to be mapped, so we can choose any port. Let's say we want to do 8080. Let's do 8080 itself, and then to the port 80 in the container, and do a docker compose up-d. And now we can check Docker desktop to get that link straight to the mapped location. Since Docker desktop wants to be slow. Yeah, okay, here it is. So we can expand that stack, click that link, see we're getting the basic NGINX landing page, which is great. That means that all the basics are working here. So since we have a good working point, no, we're not done, but we're on the way. So it'd be a great time to commit. So git status, say git add dot git commit -m, transitioning to a basic single service NGINX app with volumes, and then that's all good. So now we have those changes committed. If we make some mistakes in the future and we kind of want to come back to a commit, this might be a good place to come back to. And keep in mind, the main branch is completely as we left it. Nothing has changed over on the main branch. This is just on the PHP branch. And nothing has changed in the remote origin either. We're currently still just keeping these changes local. So next what we need to do is talk about how PHP can get run from NGINX, and now this transitions from being about Git or being about Docker to being really just something specific to the application of NGINX. And so the application NGINX has this particular configuration file that we've been working with here, and it specifies how the web server is going to work. And if you've worked with this before, you might have noticed this commented out sort of suggested config for different things. Like you can proxy PHP scripts to Apache. Apache is another web server. Or you can pass the PHP scripts to a fast CGI server. Or you could deny HT access files. You may not know what any of this means, but they're kind of getting you started with some potential common use cases for this web server. And so this happens to be exactly what we're doing in this video, is trying to get PHP running on a web server. And the thing about web servers is that a web server itself is just serving files. It's just you ask for files and it gives you back files. So PHP scripts are actually server-side code that runs to produce its output. So it's not simply a file that has all the content in there. It's a script which produces content when it is run by the PHP interpreter. Now, the NGINX container by default does not have a PHP interpreter. And the typical way that you might see this happen is that you would have all of these things installed on your particular computer. So think about the NGINX, the HTTPC. This is a little computer. So imagine this has NGINX installed on it, which we know it does, and it also had PHP installed on it. So then the typical way that NGINX would work when it was installed on a normal computer is that it would just use that other application stored and running on the same computer, which is 127.0.0.1 is an alias for the local host. So it's essentially just saying, look on another port to find the server that's going to run this PHP. And so because we're in a Dockerized setup, we're a little bit different in that we're not running this. We don't tend to run applications on a single container. If we have multiple services, we actually split those up onto different logical computers, different Docker containers, and then each of those containers can kind of just have one job. So that's why we're going to use this as a template, but we're actually going to change things a little bit. So I'm going to uncomment this fast CGI server, and I can give you a little bit of background on fast CGI so that you aren't completely confused about what this is. So if you Google fast CGI, you will find that fast CGI is a fast, open, secure web server interface that solves the performance problems of CGI. Well, you might think, I don't know what CGI is. I used to think this meant computer graphics interface or computer generated image, like you typically think of like CGI in movies, but this actually stands for the Common Gateway Interface, which is an interface that enables web servers to execute an external program to process HTTP or HTTPS user requests. So it's actually a sort of an old standard. You see 1993, 1997. Those of you who were born in the 80s or earlier are probably insulted by 1993 being a long time ago, but essentially the Common Gateway Interface is a thing that allows us to run some scripts as part of our web service activities. And so NGINX is a web server, but there are other web servers. A really common one is the Apache web server. And so commonly you'll have the Apache server installed on, say, your Linux server, and then you would have PHP installed on your Linux server. And those things would work together, maybe using the Common Gateway Interface to kind of make those things come together at once. So the details don't really matter. The point is that we want to use CGI or fast CGI or something along those lines so that we can run PHP code but actually have NGINX aware of those changes. And the way that this works, if you've ever seen in the browser bar when a website has .php at the end of its URL, you might be confused by that, because if you know about how browsers work, you know that browsers really can only see HTML and text. they can't execute PHP files. So the way that that's happening is the web server is working together with a PHP script to create that output dynamically on the server and then deliver it to the browser as plain HTML. And so that's the little trick that's going on there. The way that we implement this trick here is that we use something called the PHP FPM. Now another abbreviation. You see, we're getting closer. We found out what is fast CGI, what is CGI, and now what is FPM? It's Fast CGI Process Manager, an acronym within an acronym, and it's just a way to handle more traffic. Blah blah blah. It's a way to run PHP in conjunction with a web server. And so I happen to know that we needed to know about FPM because we're going to be using Docker. So if we go to Docker Hub PHP, there's an official image. But if you look carefully, you might think, okay, great, we can just pick any tag of the PHP image. But actually, if you look carefully, the way this image is used, a typical thing you might do with this image would be to run a PHP script inside the container. Just like if you've run a Python script inside of a container, or you've run a Go script or a Ruby file, then you just want to run that code and get the output in your console. But we're doing something a little more advanced in that we want to have a web server work together with a PHP script to create dynamic output on the server and then send it to a browser. So I know it may sound confusing, but you're just going to have to trust me that we want a version of the PHP Docker image, which is an official Docker image, by the way. We just want a version of that which automatically is set up to do FPM, which, as a reminder, FPM was the Fast CGI Process Manager. So it's just a way of doing Fast CGI, which is a way of doing CGI, which is a way of linking together a web server with PHP running. And if you're also wondering why PHP, why not Python, why not whatever, PHP has been a really popular way to do dynamic server-side content for a long time. And even if it is falling out of style, it's sort of coming back into style with things like Laravel. But it's also going to be a big skill for you to maintain PHP code because there's a lot of code that's already written in PHP that you may have to go in as a developer and work with without reinventing everything inside of that app. So we're going to look for FPM and find. This looks like a great version. It's very specific, so we know that it probably shouldn't change very often. And they'll just add new versions instead of replacing this tag. And it's built on Alpine, which is pretty small. It says it's an FPM version, so that looks great. And the thing about FPM and CGI is that they have a canonical port that they run on, which is typical for a lot of applications. You might know Postgres, the database, runs on port 5432. That's just typically the default port. For CGI, the default port is port 9000. So what we're going to be doing is adding a PHP container to our setup. So I'll just call this the PHP service, and I will build this off of the image, or not build, but set this up off of the image of PHP 8131 FPM Alpine 321. That's a mouthful. And give it a container name so that we can see it very clearly. We're going to have to give it the same volume here, but I'm going to leave that for later because we haven't talked about it. And it doesn't need any ports because if you recall how Docker networking works, these services can talk to each other on a private network by default. And so they can just talk to each other by service name. So we just need this service name as our host name that we're going to talk to on port 9000. We don't actually have to connect port 9000 to anything on the host system. And let's go back to our default conf and see how this is sort of set up. So this has a setup of the PHP container needs to know where the PHP files are going to be. What is the root? Kind of like NGINX has a root. This needs a root of where those files are going to be. And it's going to need the index. What are those indices, those index files called? Index.php. It's going to need a script name. So for a particular script name, where should it actually find that script in its own file system, wherever the PHP is running, and then it needs some parameters. So this is kind of the standard stuff. All that we have to change here is make sure that we have the code in the right place and that we have the host and port correct. So we're going from localhost to an external host, but we're going to stay on the port 9000, and we're going to have the script file name. Right now it's in a /scripts and then adding some other stuff from a variable here. We just want to make this $document_root and then that rest of that, and that's just going to say go to wherever this root is and find those files there. And so to keep this simple, we're going to mirror the exact same structure as the NGINX container inside the PHP container. So we'll have that that service is going to just look for those files inside of its own file system at user share NGINX HTML. Just for simplicity, it's going to be the exact same structure. So whatever the file is, say it's /index.php, then this is going to be the script name, and the document root is going to be the rest of this. So we have that set up, and everything else should be fine as the default. Now what we have to do is simply map that volume to the same place in that file system, since that's the paradigm we chose to use. So I'll just create the same volume over here. It's literally going to be the exact same folder mapped to the exact same folder, and this is one folder in one container, this is another folder in another container, but they get to share the same volume, and so they're viewing the same HTML and PHP files that are in that place. So as you recall, that is this folder right here. And now we can see if it will work. So to do that, I'm going to open up that terminal again, and I'll do a docker compose up-d, and when I click to this service, nothing has changed. So what the heck, why did we do this at all? Well, the purpose was not to run this file, which is an index.html file. The purpose was to run a PHP file. So a PHP file would be something like index.php. And you could do something in here like PHP, probably going to get the formatting wrong here, so I'll say PHP info. This is just a standard PHP command that will use the PHP interpreter to turn the some information about the PHP system that is running, and it's just going to turn that into HTML. So this is injecting this kind of PHP into an HTML page that then is really easy for a viewer to look at in a browser. And so now, if we were to specifically look for that file, we just get that file downloaded, which is obviously not what we want. And not even sure that that's the correct file. Okay, so it is the correct file, but it's not what we want to happen. We want to actually navigate to that file. So how can we handle that? Well, if you look closely at the location for the basic NGINX configuration, the index was allowed to be HTML, HTM, but not PHP. And that's because browsers aren't built to do PHP, so unless we have a PHP interpreter, which we do, then we shouldn't be able to do that. So I'll go ahead and put this at the end, index.php, and because we're changing the configuration of the NGINX process, which is currently running, we're going to have to actually recreate those services. So we could do down and up, or we could just do --force recreate, and that'll restart those services so that we can see what happens. And we're still getting this index.html, and so the reason is because, for one, I misspelled this, so let's fix that. But also, we're just going to continue to get this index because the order here, this is ordered. So it's saying, look for an index in this order. Look for an index.html file first. Okay, well, you found that, serve that. If you don't find that, then use this. If you don't find that, then use this. So we actually, if we want this to be the top priority, we have to move it to the top of the list. So if we run that and we reload, now what's going to happen, hopefully, is that NGINX is going to use the index.php as to serve the index, and then we get this PHP info. So this is what PHP info looks like. It's this nicely formatted setup, about what's going on. You can see my system I'm running PHP on is a Linux WSL2. That makes sense because that's the kernel of my Docker container. And so all that is good info that I might want to see in here. But this is just kind of a demo to prove that PHP is producing this. And this would not do anything if we just viewed this in a browser. It's not going to do anything. But because we have PHP running and those things are communicating correctly, you see all that is this HTML is getting produced out of this by the PHP interpreter. So the process here is maybe a little confusing if you've never seen this type of stuff before, but what's happening here is NGINX is saying on / look for an index. I'm going to look for PHP files first. I found one, so now I would return that to the user, but it's a PHP file, so the user can't use that. So I'm going to proxy that over and have this PHP service on port 9000 figure out what that means for me, so I can send it back to the user, and then this will turn that into HTML and give it back to NGINX, and then NGINX will give that back to the browser. So that's what's going on here. And to illustrate this further and how convenient just using an index naming scheme here is, and using this web server, is we can take advantage of the file folder structure of web servers to just create a new folder called let's say PHP info. And so now that's a new path on our web server, and we can easily just drag and drop this. And because this is a volume and it's not to do with the configuration, we don't actually even have to restart the container or anything. We can just reload the page, and now we'll see we're getting served index.html because there was no PHP, so it fell back to HTML. And if we navigate to /php-info, localhost, not localhost 80, but 8080, and then we'll see this PHP info thing, because it's treating this like a part of the path, and so we'll go to /php info and then find an index in there. And now, since it's the only file in there, we could even put the order back where, say, we want our priority to be HTML files get picked first over PHP files. We could put that last, and because it's the only file in here, it should still work. So we'll recreate those services, and we should see the exact same result. So I'll reload that. Looks good. Go forward to PHP info, reload that, everything works fine. So the last thing here I'm going to do is just reformat this index.html to say, welcome to the PHP demo app. Reload. We'll call it PHP demo app, and then we can use the same kind of link strategy we used in the prior site, which was to just say, please visit this link, to kind of test that out. And again, we could have the PHP be the landing page. In this case, we easily showed how that's possible, but I just want to show how this can be at a nested path. So you can say, please visit the PHP info, the PHP demo page, and then reload the page. We see PHP demo app, please visit the PHP demo page, and you get the PHP info, and you could go back and you're back at the home page. And it's a quite simple scenario now. Everything is running in terms of the service, the web service, out of one container, except the only difference is we have a second container that runs any PHP files that we might encounter. And I'll show you now how you could also, specifically if you said index.php, now you see we don't download that file, but we actually execute that file and get to see the output in the browser because NGINX is working together with the PHP FPM. now is a good time to, even though we're not completely done, we can commit, at least we have the kind of the nuts and bolts together. We just don't have the formatting or the setup correct yet. So say git status, and I'm just going to add to the README, usage. We'll add another step here of some manual changes to be documented. So git add dot git commit dash m working PHP demo with manual changes. Because remember, we made changes to these volumes the way that they were set up by the setup script. Now, we're 2 commits ahead of origin PHP, and main has not been touched, which is exactly what we wanted. So the final thing to do is identify what are those changes, and just take, in this case, a little bit of a simpler approach for how could we maintain those changes for somebody who comes up to this repo from nothing. So we could just create a folder called like templates. So it's just going to have template files that we can copy around, and we don't have to dynamically create them with Perl scripts or anything confusing like that. So to do that with the git ignore, I know we're going to have to unignore templates and everything inside templates. And then we're also going to have to put the files in here that we want, that we've made changes to. So if you recall, we made changes to the PHP info folder. We put that inside of the HTML folder. So let's Control C, click on that, Control C, and then go to templates and Control V. And we can rename this if we want, but for now we'll just leave it as that. We didn't touch the NGINX conf, but we did touch the default conf. So I'll copy that over to templates, and then I'll give these a little bit of better names. So inside of PHP info, I'll rename this to HTML folder for PHP info, and then the default conf we can call the PHP NGINX .default.conf, or -default.conf. Any name is fine. I just want those to be understandable what it is that is going in there. On a little bug that might be in here with the git config or the git ignore is that templates /*/ means any path within templates. And so this was unignoring that. I just want to unignore templates and **/*/ to unignore this templates folder. And now my git ignoring is just getting too complicated, so I'm going to do the normal approach of just ignoring the things I want to ignore. So it says untracked files or templates and volumes, so I just want to ignore volumes. And get status, okay, get add dot, get status. There we go, now everything is getting tracked. You saw it was gray. I was kind of fighting with the templates folder being ignored, so I just simplified my get ignore rather than ignoring everything by default to just unignore everything by default and then ignore the volume specifically. So now I have some folders from which I can copy those templates, and assuming I caught all of the changes I needed to make, I should be able to just add this to my init script that it's going to pull those specific pieces in. So for example, I would want to take the CP, the templates, CP-R for recursive, the templates slash, let's copy the name so I don't mistype it, HTML folder for PHP info, and copy that as volumes slash HTML slash PHP info. And because that's a folder that doesn't currently exist in there, it will actually create, it will rename this folder as that, hopefully. And then in terms of the default conf, we'll need to copy the relative path on that, and CP, we don't need -r because it's just a simple file, so we'll do NGINX default conf and copy that to volumes config confd default conf. And now we can check that. So I'll even just manually remove volumes and see, can it get set up by the script. So we see the default conf is correct here, and the PHP info folder has that PHP file that we created. And if our services are still running, should be able to simply revisit to double check that everything looks correct in here. Okay, so this is a problem because we forgot something. We forgot the part about changing the index HTML. So actually accidentally overwrote that, so we're gonna have to recreate it. That's why we test. So create just this simple link here that we used before. PHP demo, please visit the PHP info PHP demo page. Check that that looks right, and then the PHP info works fine. So we simply need to save a copy of this one. So we'll copy, go to templates and paste, and rename this to homepage.html. And then when we copy that over, we can copy the same way. CP templates homepage.html to volumes HTML index.html. So that's going to overwrite the index file with this. And this should be clearing out the config and volumes folders when it does it, so I don't need to really manually do that. You'll see that everything gets recreated. Hopefully the index has that now. Yes, it does. We still have our PHP info and our default conf. And if we go to the browser and reload, everything is working just fine. So that pretty much completes everything. We just have to update the README. And so we don't need any manual changes, so that's fine. and make sure everything looks good here. Architecture is an NGINX container serves HTTP traffic on port 8080 and uses a PHP FPM container to run the PHP scripts. Testing notes should be good. We don't need Perl anymore. And process should be the same. We can clean up our init script because we don't need anything after the exit 0 anymore. So that's pretty simple now. And we just have that templates now to copy things over so we don't have to make changes with scripts. And little challenge here is that the PHP service, that's good. So do a git status, git add dot, git status, git commit -m, fully automated PHP demo setup. And the final step would be to pull down our changes, clone the repository somewhere else, or use another copy of the local repo. Make sure we pull that PHP git status. So that would look like git pull origin PHP, which of course is what we would be pulling here by default because it's the PHP branch. But if you did this in another local repository that didn't know about the PHP branch yet, you could create a PHP branch and pull it, or you could do git switch, I believe, git switch, which would say get the origin PHP branch and check out a local branch with the name PHP. Now you can see that in the repository there are pushes, but main is completely safe as it had been before. We can go over to the PHP branch and we see 10 commits because it has the first 8 from the main, and then it also has the new commits that are only here. And of course we haven't pushed up to GitHub, so we need to do a git push and there we get all 13 commits. And even though we completely overhauled these files, the main branch is safe. So that should wrap it up for this video. Thank you for watching.